Hi, in this video we will learn about points and vectors in plane and review main points of these two objects, how they are related, and in particular we will fix conventions and notations that we will use throughout the course. Okay, so let me form two columns, one for points and one for vectors. And as we go on, I will put more items in these two columns. Well, first thing is that when you work in a plane, so in this case the screen or what you're seeing in front of you on the screen, well, this is two-dimensional. Well, points are, well, obviously the piece, the smallest elements that form this screen. But vectors are what we call directed line segments. Directed line segments. Well, here, this definition here gives us two things that what is important for us in the case of vectors is one, direction, and being line segment means that the length is also important, and these are two things that define a vector. For us in this book, the way we will call points and vectors, or how we denote them, is very particular. For points, we would use uppercase English letters, like A, then B, P, Q. And in the case of vectors, your book chooses to use boldface, lowercase English letters. But since I cannot do the boldface in my writings, so we will use an arrow on top. So we will use lowercase u, v, a, b, and there's almost nothing else I can do, just fix this thing. And this notation we will use all over the videos that you will see for this course. A good thing about this notation is that there is also a very good relation with another other part of the convention we will use. When we have a vector, it is basically displacement from a point to another point. So it will be from a point A to point B. Yes. Sometimes we point and fix these points and call them the A, we call this initial point, and the B we call the terminal point. Terminal point. Well, sometimes you will hear me saying tail and head for these guys. And when you have a directed line segment from A to B, a standard notation that we will use for this will be A, B. So this is a vector, and this way our convention of putting an arrow on lowercase letters also makes sense, and it is consistent with the with this new notation. Okay, so far this is very generality. How you see everything here is, well, basically geometrically defined these ways, but to work with these objects we need to make them algebraic. We need to find a way to represent them algebraically. For that we need a coordinate system. And the most famous one, the Cartesian coordinate system, or what the plane with Cartesian coordinates, which we call Cartesian plane. Well, in this case, every point on this plane can be represented by, so algebraically represent, algebraic representation. So every point on the plane, well, you can find what is the x coordinate. Let me denote it by be a x naught and y coordinate. And the way we denote these guys is an ordered pair. So x0, y0. So it's an ordered pair of numbers. And the notation we will use here is that, well, we would use round bracket for the points. And when it comes to vectors, we again use ordered pair, so vector u, but this time we will use the square brackets. So this is one of the conventions that your book uses. And again, it is ordered pair. It means what? It means that the first coordinate and the second coordinates are different. So if you have a vector like 1, 2, it is not the same thing as 2, 1. Or if you have a point 0, 1, it is not the same thing as 1, 0. The order matters. The first one and the second one. Well, these numbers here, x0 and y0 for the points are called coordinates. And they have the meaning that we have. So the coordinate, x coordinate, y coordinates. Yes, but coordinates. And for the vectors, they don't mean as the points coordinate mean. So the numbers here a, b are called components. And again, we are using these ones are not the coordinates you read from the xy axis. These have a little bit different notion. So this brings us to something which is called equality. Equality of points and vectors. For the case of points, about 2 points if they coincide, so points are equal if they coincide. For vectors, it's a little bit different. 2 vectors are equal if they have same length and direction. So if they have the same length and direction, although they may start from different, they may have different initial points, but if they have the same length and they have the same direction, that's it. They are equal, basically. In other words, if I want to show something here, a vector like this is the same as, let me copy and then paste, same as this one. And if I paste another one, same as this one, because these have the same direction. And this one here, all of them have the same length. Well, I copied and paste, and they are starting from different points. Yes, they are starting from different. One starts from the origin, one starts from the, but these guys are the same. So as you can see, geometrically it is a little bit strange, but when it comes algebraically, when 2 points are same if their corresponding coordinate corresponding coordinates are equal. So what I mean is that x1, y1 is equal to x2, y2 if we have x1 equals to x2, the first component and the first coordinate equals to first coordinate, and y1 equal to y2. And similar thing happens here. The two vectors are equal if their corresponding components are equal. Well, it means that AB is equal to CD as vectors if and only if A equals to C, the first component equal to first component, second equal to second. So that is equality in two different things. And something that the relation between these two are important. So from a point when we have, so here I will just for a given point, so any point you give me, I cannot make a vector at the first stage just using one vector. I need an initial and terminal points. With one, I cannot do anything. But there is, when you have Cartesian coordinates, there is a very good point, the origin. We denote it by O. So for any given vector, we can create, any given point A, well, if it has coordinates, say, x0, y0, we can create a vector called position vector, which is basically OA, the vector with initial point origin and the terminal point, the given point. So this position vector will have exactly same components as the coordinates of A's. In other words, you just do this thing. So the vector, if you have a point, say 1, 2, the vector coming from the origin, this is 0, 0, the vector from coming the origin, so this is OA would be, this is now a vector, so I will use square, it would be the same components. How about in general, if we have A, which is x0, y0, and B, which is x1, y1, then we can make always O, this is not conclusion, I'm just trying to say, we can make vector AB. What are the coordinates of this guy? Well, the components of this guy, you subtract the components of the end point from the starting point, initial point. So for x, you have x1 minus x0, y1 minus y0. And this way you have the components of the vector. And as we discussed before, let me just do one example at least here. Example, the vector from A to B is, well, first of all, AB. And how do we find it? Use the square brackets because this is a vector. So end point minus the starting point. End point minus starting point. So then AB is -1 and 1. So that is one important thing, that how the points and vectors are related. Another thing that we need to know is, well, now that for any given vector, so we can have this vector 1, -1 can be, actually it is of this form, so in the coordinate. So we can have any other one, something like this, something like that, something like that. But the one, all of these ones, there is one specific one. The vector, vector with initial point origin, so if it starts from the origin, is called, is said, actually it's just name, is in the standard form, standard position. And when something is in the standard position, the components are exactly the coordinates of the endpoint. So if we have this thing here, starting from the origin, goes there, this is a vector v, is in standard form, then the endpoint, whatever a is going to have exactly same coordinates. Well, just summary, you have to know the difference in the notations, round bracket versus square bracket, the meaning of the equality, and the meaning of components and coordinates. And at the end, how you can go from point or 2 points to vectors.